Hello, and welcome to our webinar, Increasing AI Tool Adoption by Frontline Workers. I'm Elizabeth Heichler, Editorial Director at MIT Sloan Management Review, and I will be your moderator. Now to today's topic. Many AI implementations are falling short of their goals to help organizations improve product and service quality, reduce costs, and increase revenues. The reason is that end users often resist adopting AI tools, especially those that guide decision-making, because they see few benefits for themselves, and the new tools often add to their workload while taking away some of their autonomy. However, research by Kellogg, Mark Sendak, and Suresh Balu has found that when developers ensure that end users' concerns about workflow and autonomy are addressed, conflicting stakeholder interests can be reconciled and AI tools more readily adopted. Kate is the David J. McGrath Jr. Professor of Management and Innovation here at the MIT Sloan School. Mark and Suresh are at the Duke Institute for Health Innovation, where Mark is the Population, Health, and Data Science Lead, and Suresh is Program Director, along with his role as Associate Dean for Innovation and Partnership for the Duke University School of Medicine. Welcome, Kate, Mark, and Suresh.
Thanks, Elizabeth. All right, everyone, let's get this webinar started. Here is our punchline. Employees don't like solutions that make their lives worse. For organizations, AI solutions can result in increased revenue, reduced cost, and improved quality. But there's three ways that AI is different from other technologies, and we'll talk about these. It's predictive, it's laborious, and it's prescriptive. So that means that for employees, it can result in few benefits, additional labor, and decreased autonomy. We've been doing research at Duke over the last 5 years, and we've identified 6 tactics for successfully implementing solutions. We've compared implementations that are successful versus those that are failed, and these 6 tactics are generalizable across industries. So I'm going to start by presenting 3 examples of how you would use these tactics in these other industries, and then I'm going to hand it off to Mark, who's going to present examples from Duke Health. We'll finish with Q&A. So here are the 6 tactics, and let's take one at a time. First, because AI is predictive, you need to increase benefits for end users. I'm going to use an example of an AI solution for HR recruiters, and in particular for sourcers. So sourcers for this organization located and attracted candidates. They identified candidates with difficult to find technical skills, engaged with them to speak with them about the company, and then handed them off to HR interviewers to be interviewed. And the actions taken upstream by these sourcers had large consequences for the downstream interviewers because the interviewers then need to screen them for mutual fit, and then the HR closers were the ones that offered the jobs. So the interviewers really wanted the sourcers to find candidates who are more likely to accept offers once they were offered. And so they came to the AI developers and they said, give us a solution that will help the sourcers predict which candidates will be accepting the offers. The problem for that was that the interviewers were not the true end users for the tool. It was actually the sourcers who were going to need to use the tool. And they had different needs. They wanted to hit their quotas by finding all candidates with the desired skills, regardless of how likely they were to accept the offer. So the developers were smart, and they said, all right, so let's see what we can do to address the pain points of the sourcers. And what they found out was for the sourcers, a big problem was that they would hand off these candidates and they would just sit there in the system for 2 weeks before the interviewers could interview them because the interviewers didn't have enough bandwidth. So the developers said, okay, why don't we do something different? We're going to introduce a pre-interview assessment part of this, where now candidates are going to get handed off and they're going to have to do an assessment of their coding skills before they move to the interview stage. And so you may be there sitting there thinking, well, wait a minute, that's not data science. Exactly. And I had a developer just give me a great analogy for this, and that is that for any AI solution, it's like an ice cream sundae where the data science is the cherry on top. So if you think about your own life and all the things you're trying to get done, what you really want to do is be able to get your regular work done faster and more easily. And that's the Sunday. And then that's great if you can also then do these really cool things and do your job differently. That's the cherry on top, but you need to first give them the Sunday. They also were smart because they rewarded the outcomes the solution was designed to improve. And so historically, the sourcers had been rewarded just for the number of candidates they passed on with who fit the desired skills. And they changed the reward system. So now they would also be rewarded for the number of candidates who accepted offers. So this sounds so easy as you guys sit back there in your offices and you think, of course, I know how to think about the needs of end users. But what we found is that it's easier said than done for two reasons. The first is that these end users always bring their own requirements, and that complicates development. And interestingly, it's not usually the developers that have trouble with that. It's usually the people who come to the developers asking for the solution. So the HR interviewers in this case, who say, oh yeah, we know the sourcers are the true end users, but let's not get them involved yet. Let's get a little further along before we bother them and get them involved. But you need to get them involved from day one. And then the second reason it's hard is that developers don't control the reward system, right? So they need to upwardly influence top managers in order to get the reward system changed. And that happened in this case also. But for AI implementation to be successful, you are going to need to increase end user benefits in these two ways. The next thing about AI is it's very laborious and you need to reduce the labor for the end users. I'm going to use an example of an AI solution for salespeople. The salespeople in this organization sold manufacturers' product in large quantities to wholesalers and retail store chains. And they spent a lot of their time building personal relationships with customers in order to identify new opportunities. So they were very busy, the salespeople, generating leads, making calls, responding to emails in order to hit their sales targets. So they're busy people anyway, and now you're asking them to do all this labor. It's not completely new that you've asked for feedback for end users. So for an example, in this organization, they had a CRM system for sales. And whenever they did a new iteration of development, they would ask for feedback from the end users. But what's different about AI is it requires feedback in all of these different steps. And all of you out there who are implementing AI know that it takes a long time to do, and it's very laborious to do all of these steps. And so you need to figure out how to reduce the labor for the end users that are involved in doing these steps. So in this organization, they enlisted the head of process improvement, who was the one who wanted the tool in the first place, by the way. And the salespeople in the beginning really not very interested in this tool. And they got the head of process improvement to perform a lot of this data work originally. And they also initially built the model, so it required a smaller amount of training data in order to show proof of concept to the salespeople and show them what the promise of this tool was. They also reduced integration work for the end users. And they did this by automating the data inputting required to use the tool as much as possible. And they also pre-staged the interface to meet the salespeople's needs. So just to give you an example of that, the salespeople in this organization did what's called white space analysis, where for any given client, they would look at what are they already buying versus what's the full product line that they could be buying based on their industry and based on particular demographics. So the AI solution developers made it easier for them to do that white space analysis, again, giving them that whole ice cream sundae. Again, sorry, easier said than done for two reasons. First of all, end users are great at the data work because they're the ones that know the ins and outs of the data. They know the idiosyncrasies, the best outcome measures. So of course, the developers would love to have their input as much as possible. And then when it comes to integration work, they're also the best. They know the daily workflow. They know where this solution should best fit in. And the developers know that if they enlist their help, then these end users will also serve as super users to persuade their peers to use the solution. So the answer is not to completely avoid asking end users for help. It's just to use the labor of the end users very judiciously. Finally, because AI is prescriptive, you need to protect the autonomy of end users. And here I'm going to use an example for a solution for fashion buyers from my colleague, Melissa Valentine at Stanford. And let me just start by saying it's pretty funny that I'm going to give you guys a lesson on fashion. If I have any friends on this webinar, they're getting a really big kick out of this right now. But it's a great example, so let's see how I do. Fashion buyers selected and ordered which clothing would be sold to gain maximum profit. So they traveled the world looking at the fashion runways, what are the best pieces. Then they combined their knowledge of fashion with their business sense to decide what mix of brands to buy. And that's what you would then see in the spring season, you know, online or when you're in stores, is what those fashion buyers decided to buy. So top managers had always used a detailed planning process to better help control the fashion buyer decision making. But AI was just a whole different level here, where now it was going to use historical data that incorporated the intuition of the fashion buyers that they'd been using for years to provide highly specific recommendations and allow managers to track whether the buyers were following them. And so perhaps not surprisingly, the buyer said, you know, wait a minute, you know, we don't love the idea of introducing this solution that's going to allow people outside of fashion buying who know nothing about fashion to be shaping and critiquing our decision making. So the AI developers were smart. They avoided infringing on the end user core tasks. So in fashion buying, what the fashion buyers love to do was the creative task of knowing fashion and knowing what that assortment could be. That's why they went into this job in the first place. What they didn't like, the scut work, was now figuring out which vendors are going to be the ones to supply those different fashion items. And so what the developers did was they developed a solution that allowed the buyers to dictate the assortment, but help them allocate sizes across vendors and do the scut work piece that they didn't like to do. They also ask the end users to help evaluate the solution. So the end users initially said, you know, thank you very much for your fancy AI solution, but I like my current planning process. I understand my technology. I'm not going to look dumb in front of people. I really know the ins and outs. I'm not interested. And so the developer said, okay, that's fine. Do you mind helping us design an A/B test to evaluate the performance of your current system versus this new system? And they did that so then the fashion buyers would see, wow, this new system is actually pretty good. So great, let's protect autonomy. Easier said than done. Here's why. First of all, intervening around core tasks promises to yield greater gains. So if you think about it, fashion buying is high up in the value chain. If you intervene there with an AI solution, you are going to affect everything downstream in terms of revenues and gross margins. If you intervene just around the vendor piece, it's a lot less impact. But what we found is intervening around a circumscribed set of tasks with a solution that actually gets used is a lot more effective than building this perfect AI solution that intervenes in exactly where you want to, but then doesn't get used. The second thing that's hard is when you do involve these end users, especially if they're not so interested in this solution to begin with, they are going to select the most challenging tests for you to do to prove your solution. So that's not so easy. But again, we have found that it's necessary to protect autonomy if you want this to be successful. So we suggest that you add these 6 tactics to your toolkit. Why? Because success doesn't arise from big data and sparkling technologies. Instead, it depends on these end users on the ground. So here's the stark reality. If you want to be successful, you need to increase values for those who are working on the front lines in order for AI to function in the real world. So with that, I'm going to go ahead and hand this off to my colleague, Mark Sendak, who's gonna take you through the Duke examples.
Thank you, Kate, for walking us through the 6 tactics. Hi, everybody. My name is Mark Sendak, and I'm speaking to you from the Duke Institute for Health Innovation, where I work as a physician entrepreneur. And I'm going to take the 6 tactics that Kate just walked us through, and I'm going to ground them in examples within healthcare, a very kind of professional services oriented industry. So at Duke Health, we have 2 structured ways of identifying projects for innovations. On the left-hand side, this is our annual request for applications, where we align senior strategic priorities from our leadership with the needs of frontline workers. We've done about 100 projects through that process. And then on the right-hand side, we have more of an innovation Shark Tank competition, where we help commercialize IP and inventions built at the university. So I'm going to go through the same 6 tactics in the same buckets. This will likely sound familiar. You just heard about the great use cases that Kate brought up from non-healthcare industry, and I'm going to tell you what this looks like within a health system. So to kick things off, I want to help orient things around patient experiences and provider experiences. So we're going to kick things off with a patient. This could be a family member. This could be yourself if you have experience with a chronic illness, where typically there's some trajectory that starts on the left-hand side with a healthy adult. They may develop an early stage chronic disease. This could be diabetes, hypertension, kidney disease. Gradually over time, that condition can worsen. The kidney function can worsen, liver function can worsen, and ultimately for some patients, the organ function gets so bad that we need to start looking at a way to replace that organ. And so what that looks like at a place like Duke Health is that that individual patient is going to end up interacting with our system differently. So they may start by seeing a primary care physician, but as a kidney disease, liver disease, whatever organ it is, as that deteriorates, they need to see additional specialists. And ultimately, on the right-hand side, you see that organ transplantation is a very high cost multidisciplinary team where you have very specialized surgeons and immunotherapies. So it really goes from upstream to downstream and more complex in the number of people involved. So a lot of the problems that we work on and that we build AI or ML solutions for is to prevent some downstream progression and prevent the bad outcomes from happening. But like Kate mentioned with the interviewers and the sourcers in the HR process, if we're trying to prevent downstream progression, that often requires that there's somebody earlier in the process, which is really often the primary care doctor, that is intervening earlier. And so this may mean that the primary care doc has to do more to manage the chronic diseases to really make sure that these conditions don't worsen. So we all here may have heard how burdened healthcare workers are. So I'm going to start with the example of a primary care physician. Primary care docs really do have to manage everything. So we'll start off by talking about kidney disease, where the kidney disease may progress. A patient may have to go see a kidney specialist, and the kidney specialist may tell the primary care doc, you know, you could have done more to prevent the kidney disease progression. Same for patients with diabetes. There's going to be endocrinologists who see really late stage diabetes. Maybe they see kidney disease. You can get lose your vision, retinal complications from diabetes. So you're going to see endocrinologists who tell the primary care docs, you could have done more earlier to manage this condition. You could have done more earlier to manage heart disease, to manage liver disease, to manage lung disease. The list goes on. So at the end of the day, you get these upstream workers who are really burdened by all of these requests from the downstream specialists, telling them, hey, we could have done more earlier and prevented these downstream complications. So when we're building AI, this really does change the tactics. And so this first tactic is identifying who your end user is and addressing their problems. So let's go back to our primary care doc. So we're going to use the example of kidney disease, where there's nephrologists who are specialists in caring for kidney disease patients, and they're telling the primary care docs, you could have done more earlier to manage this kidney disease. But we have to take a step back and think about, okay, what are the primary care doctors' pain points? First off, they have limited time to address all of the conditions. So what we did with the AI is we helped a specialist, a kidney specialist, send recommendations directly to the PCP to help them manage that kidney disease, to help relieve some of the burden of having to think about that specific condition. Another problem for PCPs is that they go from one 15-minute visit to the next 15-minute visit, and that's day after day after day. So I'm sure folks in the audience have experienced this. When you walk into a doctor's appointment, you often have to reiterate the same thing multiple times because there's not a lot of opportunity to prepare for these visits. And so what we did with the AI is that the specialist sends the recommendation immediately before the visit. That way the information is teed up for the PCP to be able to act on it. And then lastly, it's the fact that, like I mentioned before, PCPs go in and out of visits all day, and they may not have the opportunity to really follow up with patients and make sure that that patient with kidney disease, where they recommended a change in the medication dose or recommended that they see a dietitian or a kidney specialist, they may not actually know whether that happens. So what we did with the AI is we also complemented the tool with care managers who would actually follow up on patients. The second tactic, building off of Kate's examples, is to align the outcomes and share in the reward with your true end users, which in our case is the primary care doctor. The reality is, if you are able to prevent progression of kidney disease, you actually end up saving a health insurer or a payer a lot of money. So to put this in dollar estimates, a dialysis crash start that happens in the hospital can cost upward of $80,000. And you've got to imagine, if you have these kidney specialists telling the PCPs, this could have been avoided if we acted sooner, ultimately, we want to align the incentives so the PCP can help also receive some of the shared savings from avoiding these bad outcomes for kidney disease. So we actually did work with our health system leader to help align incentives for the downstream and upstream users. The next bucket of tactics relates to the labor involved in building and validating AI systems. So let's go back to our primary care doc example. We have all of these downstream specialists telling the primary care doc, hey, you could have managed this chronic disease earlier and prevented these bad outcomes. Unfortunately, in healthcare, though, those primary care docs aren't the only generalists who get that kind of feedback all the time. Another setting where this happens is emergency departments. Probably another setting that many folks in this audience are familiar with. You show up and the ED doc has to manage whatever comes their way. So, for example, you have a certain type of heart attack, an NSTEMI, that is lower risk, and patients don't have to go to the ICU when they have this type of heart attack. They have a better chance of doing well in the hospital and returning home. But what happens is that the ED docs, in the time pressure that they face, going from one patient to the next, they're just trying to make sure that patients get the care they need, so they send a lot of these patients to the intensive care unit. So you have intensive care unit docs going down to the ED and saying, hey, if you identified this disease sooner and you recognize that this was a low-risk condition, you actually don't need to send these patients to the ICU. That's a really high-cost resource, and we can use that bed for somebody else. Something similar happens for sepsis. You have the hospital specialists coming down to the ED saying, hey, if you had identified and started treating sepsis sooner, we could have avoided the bad outcomes for our patients in the hospital. The ED docs are even going upstream from their setting, trying to say, okay, can we change EMS routing? So EMS, if you're able to route patients to the other hospital, you can make it more efficient. When there's patients backing up in the waiting room and you're waiting hours to see folks, people are going to the ED doc saying, hey, can you improve telemedicine within your setting? That way we can see people in the waiting room more quickly. And then the last example that we'll build off of, it relates to blood clots that go to your lungs, called pulmonary embolisms. And once again, this is trying to tell the ED docs, hey, these low-risk patients, they don't need to come to the hospital. You can actually send them back home. So these ED docs, similar to the primary care docs, they really feel like they carry the weight of the world. And I know what this looks like personally. My wife is a pediatrician and a primary care doc. And literally day after day, you're only able to manage a very small portion of the things that you encounter. So when we're building technologies to try to improve how we manage these conditions, we have to be thinking about how do we deploy the Mack trucks to remove some of that labor that's falling on these upstream users who are inundated with requests to do their jobs better. So tactic 3 is how do we reduce the labor on those upstream end users to build out the data sets for AI model development. So what we did in this case is we actually asked the downstream specialists who care for pulmonary embolism to adjudicate the cases, make sure that we were defining our outcome accurately. Outcome definition is probably one of the most important things that you do when building an AI model. These downstream specialists, they did all the QA, quality assurance, quality control for the inputs of the model, making sure that the data that was being fed to the model to learn from was all valid. And then the third thing was we often run our models in what we call a silent mode. And this is when we run it prospectively without actually exposing the end user to the algorithm, just to make sure that it works in a production setting. And our beta testers during this silent mode were the specialists, and they took on that labor. So really, we do everything and try to minimize anything that we ask these inundated upstream workers to take on as we develop the AI solutions. The next tactic is when you actually go to integrate, how do you minimize burden for use of the AI tool? So going back to our pulmonary embolism use case, we have the ED docs who carry the weight of the world, and they're being told, hey, these low risk patients with pulmonary embolisms, you can actually send them home. The challenge here is that the ED docs are reluctant to send patients home unless if they know that the patient is going to get the care they receive outside of the hospital. So what did we do? We built the AI solution in a way where patients who are identified as having this low risk pulmonary embolism, there's a notification sent to a care manager who schedules the appointment in clinic 3 to 5 days after that emergency department encounter. So literally, it's the notification sent to schedule the appointment, and then the ED doc is told, hey, this is a low-risk patient. We've already coordinated things to make sure that the patient can be safely seen at home, and this patient can be safely discharged. So the first two use cases, I talked about healthcare examples, which is a big part of my life working at the Duke Institute for Health Innovation. The last two tactics, I'm going to ground in experience from a different part of my life as the father of two young girls. So these are characters I've gotten to know really well over the last 5-6 years. You can probably imagine with two daughters how important Frozen is to our family. So on the right-hand side, you have Elsa. So Elsa is really kind of one of the main drivers of the Frozen series, and hence the name Frozen. It comes from the fact that Elsa has magical powers to freeze anything. She can turn anything to ice. And so she has these magical powers. She is seen as an outcast in her community because of these magical powers. But at her core, she identifies with these powers and with what it gives her the ability to do. So she has this tension of having magical powers, not being really warmly accepted by her community. And she's a princess. So she's the oldest daughter in a royal family. And she comes to terms with the fact that she really is not eager to take on a leadership role within her community and within her kingdom. Thankfully, she has this amazing younger sister, Anna. Anna has grown up in Elsa's shadow in some ways and looks up to her older sister. She is fascinated with the magical powers of her older sister, but she understands that her older sister needs protection and that she's seen as an outcast, and the things that her older sister identifies with are really seen as kind of scary or intimidating by others within the kingdom. And Anna is eager to take on a leadership role in her kingdom and kind of emerges in the series as the heir to the throne. So we have Elsa and Anna's throughout our own organizations. And I'll try to map these to the org structure that Kate went through, where there are many examples of frontline workers with magical powers that we are trying to further equip with tools that we're significantly investing in. These tools can be intimidating. They can make folks feel like they have the ability to do things that they wouldn't be able to do as leaders in the organization. And those frontline workers need protection from managers and organizational leaders that more fit the character of Anna. And so this is kind of one of the most tense scenes in the first Frozen movie, where Elsa ends up leaving the kingdom. She seeks solace in a large ice kind of castle that she builds herself. And many of the villagers, they go out to try to encourage her to come back and stop using her power. And for Elsa, this is really kind of scary, and she has to kind of fight back with the villagers to keep her core tasks and her ability to continue using the powers that she has. And her sister ends up intervening and helping kind of mediate the need for Elsa to be able to really embrace and use her special powers. The last tactic is more modeled off of the sequel in the series, Frozen 2, where Elsa and Anna develop kind of a common framework and model defining under which conditions can the magical powers most advance the interests of the kingdom. How should the magical powers be used versus not used? Where should Elsa focus her efforts? And what should she be prioritizing? What are the parameters by which she should be using her powers? And the second movie kind of really brings together the two sisters, where you have this highly equipped, talented frontline out there in the community using magical powers, and a leader in the kingdom who is protecting and making sure that her sister's powers are respected within the community. So I hope that this helps map these different types of roles and these different types of tactics to all of our organizations. And we're going to kind of review the 6 tactics. We bucket them into these predictive AI, laborious AI, prescriptive AI. And I hope the examples that we've given you from other non-healthcare industries, fashion, hiring, grounded in healthcare examples, as well as other types of characters that folks on the call may be familiar with. So I'm going to stop sharing my screen, and we're going to be going to a Q&A.
Great, thank you so much. Great presentation. glad to have you all back with us. We'd like to remind our audience that we welcome your questions. We've had some come in during the presentation, but we would love to have more. So you can submit those using the questions module on the GoToWebinar control panel. So just to kick things off, and I'll address this to maybe whoever wants to grab this. You know, are there important differences in how you apply the tactics for AI solutions that are built internally versus those that are purchased from an external vendor? I don't know if you want to grab that, Mark, maybe, or.
Yeah, so I'll kick off, and then Suresh, if there's anything you want to add. So I'll talk through one of our examples. We talked about kidney disease, and that was an example where we used an AI tool that was built externally. And so even within the examples we've talked about, there's both, where some of the algorithms we curate our own data for, and then we build those internally. Other times there's well-validated external studies or products on the market that will then integrate. I would say one piece that is different. When you build the tool internally, there's a lot more of the labor required to validate the inputs and validate the outputs. So we have to really bring together the clinical specialists, agree on what the relevant information is, what's the right way to define the outcome, adjudicate those outcomes. Oftentimes we have multiple comparisons, so there's like 3 variations of how we could define it. Whereas when we bring in an externally developed solution, a lot of that expert consensus is already built. And typically it's a specialist or an expert within our own setting who's kind of like handing us a publication saying, hey, this is well accepted in our profession as kind of the gold standard for what other sites are doing in terms of risk prediction. Can we use this? So that's the major difference, is the amount of end user labor going into the validation of the inputs and outputs. But the other tactics are relatively consistent, how we do the workflow integration and everything else.
Right. Well, and just to follow up on that question, is there a difference in, you know, to the extent to which users along the process want better understanding of how the tool is working? You probably have a bit more visibility into your own. How does that play out with externally purchased tools?
So you want to go, Suresh?
Yeah, I think that when we start with an external tool, that is that information asymmetry. So we need to certainly address that right from the beginning in terms of, is it the right set of outcome? What are the limitations? I think those things have to be captured in a structured form so that this is incorporated into the education of that specific tool that's being developed and validated, and then presented both to the end user and all the other users as well. Other stakeholders will touch upon that tool. Otherwise, it becomes difficult to engage and drive adoption and see the returns. Mm-hmm. Mark, anything else?
Yeah, one thing to build off Suresh's comment is one of the ways that we address the information asymmetry is by doing the silent trials. So whether it's internal or external, every clinician in our setting, before they use a tool for their own patient care prospectively, they want to know, how does this work for my patients? And so we anticipate that. And it doesn't matter whether we built the tool or the tool was built elsewhere. Before we actually go to folks and try to get them ready for a rollout, we try to give them the information saying, hey, by the way, we've already done the analysis. This is how it works in this setting.
Right. Okay, great. Thank you, Mark. Now, here's a very general advice question, which I'm going to kick to Kate, since you work with a lot of practitioners. This audience member is a business manager working with a team of data scientists and engineers. What advice do you have for a non-technical person collaborating with AI ML experts so that we are all speaking the same language? And that's a very broad question, but I think you probably understand the sentiment that it's coming from and any thoughts you have.
And so, first of all, this is what's known as a cold call, guys, in business school. And now I'm on the receiving end, so I can see how this feels from the other side. So is the questioner asking, they are the person with the non-technical background?
They are a business manager working with that team and looking for how to.
Okay, so I think that the easiest thing I would say is this is where boundary spanners and brokers are really important, right? And in organizations, product managers often play this role between sort of like top managers and domain experts on the one hand, and then the AI developers on the other hand. So I guess I would say, of course, you know, as a manager, get yourself up to speed as much as you can, learn as much about the technical as you can. But the reality is that you're not going to be able to learn everything you need to know to be really effective in the detailed development. And that's where people like product managers are helpful.
Right. Okay, great. Thank you. And then another question, I'll toss this out to whoever wants to grab it, which is, you know, how do you measure the impact of these tactics? You know, how do you measure adoption and contribution of AI technology?
You know, so this is interesting because I was recently asked by someone at a research site, you know, tell me what is a good adoption rate? And so that just sparked me reaching out to my networks and asking. And so what I found interesting in this is that sometimes companies can really measure this very closely at the end user level. You know, like they can tell, is the end user hovering over the solution? How much are they engaging? They have all these very detailed measurements. And then at a place like Duke, they may be measuring this by looking at the impact more than the very detailed use. So maybe Suresh or Mark, you guys could give a quick answer, like how do you measure impact in your setting?
Yeah.
I think of
Go ahead, Mark.
I think of the phrase like competing for eyeballs, and I would say that that is a more typical lens to look at things when you're trying to present something to somebody and you're competing for real estate where they're looking. And so there's a lot of implementations that are firing pop-ups or notifications. We generally try to avoid that type of implementation. So we more try to structure our products where somebody is responsible for using a tool and acting on things that they are presented, and there should be very little distraction from their time spent using that tool. So that's why we typically go to the next step and say, how do we measure effectiveness of the tool? Because it is built in that there's labor involved in the tool use, and that labor is typically dedicated for use of the tool.
Right. Okay. Well, and then keeping on this theme of impact and maybe rolling up to organizational politics a bit, and Suresh, I think with given your role there, this might be a good one for you. How, given the enormous investments that your organization is making, how do you demonstrate value and demonstrate impact sort of to organizational leaders to keep these projects going, keep this work going?
We'll share what we've been doing here and how we've been demonstrating that in a much more practical way of doing things. We are an innovation team, so we have very clear guiding principles by which we take on projects. Every single project or an idea or a concept that we touch upon, certainly the very first aspect is a solution is built to show value. It's built to integrate in the sense that most of these AI tools do not generate value if it does not get integrated into the clinical workflow. So adoption and continuous use is an important aspect of it. That's why I think going through the 6 items as to how to really engage and drive adoption is an important aspect that we discussed today. And then certainly we look at ability to scale as well, doing all this stuff in a responsible fashion. So when we take on a project, right at the outset, we clearly define the outcomes that we are going after, along with the right set of measures specific milestones and the risk mitigation steps. And our evaluation pieces fall into typically four different categories. One is the clinical outcomes that we are looking for. The second is certainly the process and adoption measures, efficiency measures, those type of attributes on a project specific basis. Third is cost and economics aspects of it, certainly figure in. And the fourth one is certainly falls into the equity and how do we really address the health disparities as well. These are the four different categories that we look at. But certainly right through the whole AI adoption piece, we look at, can we reduce the burden or the workload on the clinicians who are using those set of tools? Otherwise, adoption just goes away. So these are the four basic categories that we look at and we demonstrate on a project by project basis. Thank you.
Okay, great, thank you. Now I have another question that I think we can look at from both maybe generally, and I might ask Kate to give us her thoughts, and then also a little bit of what's Duke doing in this area, and that is how important is it to monitor model drift in these kinds of implementations, and what are I think we'd be interested to hear as from Duke about if you have any procedures by which frontline users are giving feedback to the team, but also I'm interested, Kate, in just your overall sense of how important that is to do, and maybe if you think frontline users have a role to play.
So I guess what I'll say is that we have absolutely seen that a solution gets put out there by developers and you really have no idea who is going to grab hold of that solution and want to use it and maybe not understand what they're using it for. So that when I think of model drift, like one thing is it even the people that you designed this for who are the ones that end up using it? And if not, you need to find out who is using it and what are they using it for, and do they really understand the tool well enough to be using it accurately. And then the second thing on the model drift, when it is being used by the users, is what can you do to continue to iterate as you learn, as you see what the end users are actually doing? How can you feed that back into the solution? And I think there's a big myth in AI that it's always a learning model. And I've just seen this again and again. It's not always a learning model. In fact, in many cases right now, it is not automatically a learning model, what you see out there in the wild. And so what it really is people using it and then development teams seeing what they're doing and then improving the tool as a result. So that's what I've seen. I don't know, Mark and Suresh, if you want to say how you work with model drift at Duke.
So I want to go off of Kate, where I almost view drift, you can imagine, like, on one hand, you have the drift of the technology infrastructure that the AI is plugged into. On the other hand, you can have drift in the process and people and workflows that are putting the tool into practice. So when it comes to the technology infrastructure, we see changes all the time. There's new ways to measure labs. There's new medications that are given. There's new monitors that are purchased. Like, our small innovation team doesn't control the supply chain of Duke Health. So we have to be very proactive about monitoring changes in data inputs and representation and updating on typically a biannual basis the way that we map our model to the data input sources. On the other hand, just to give some examples of process and workflow shift, one example is where you're seeing successful adoption in one setting, and going to Kate's point, somebody starts trying to use the tool for an adjacent use case where it may or may not be appropriate. Another example is a lot of our tools, one of the follow-up actions is some communication between different types of specialists. And there's instances where we launch a tool with one expectation around communication, but then that deteriorates over time. And instead of calling people, people are just sending asynchronous texts. And so we have to monitor, okay, are the downstream actions still being conducted with the same rigor? And how do we continue to train people, continue to communicate why the structure is important, all of those things.
Got it. Thank you. And let's see, I'm not sure if this next question is relevant to you guys or not, but I will toss it out there. You may have opinions, if not experience. Can you comment on the pros and cons of using synthetic data for prototyping and accelerating model development?
Okay, guys, so I'm a qualitative researcher. No way am I touching this one. I go right to my Duke Tech people.
Do you want to start, Suresh, or do you want me to?
Please.
Okay, so I would say where we use synthetic data or de-identified data, because you can say there's a spectrum of the proprietary or confidential nature of data.
Mm-hmm.
So whenever you're getting to the point of needing to validate something for operational use, you have to be using the identified proprietary confidential data.
Mm-hmm.
But you can gradually progress across that spectrum. So environments in which we are very comfortable using synthetic or completely de-identified data is training.
Mm-hmm.
So when we're bringing new people into the organization, trying to help teach them our process, our workflows, how to work with data, synthetic data can be perfectly fine. The other is just testing of the technology. So when we take tools that we've built internally and we're trying to validate them in new environments, we can install them in a new environment and then run it on synthetic or test data. That is it's kind of like a canned problem set where we know the inputs, we know the outputs, we're just making sure that it functions. But I would say that the closer you get to needing to validate the clinical utility, the more you need to start getting into confidential proprietary data sets.
Mm-hmm. Got it. Okay, thank you.
One additional use for synthetic data is development of workforce in terms of training and educating. We have found significant value add in those because that's an important aspect of that.
Great. And that was a perfect transition because the next question that I had teed up was in fact about training and educating users. So here it is. We've heard that it's important for frontline users to understand the nature of AI decision to support output, that it's a prediction with a certain level of confidence, not a so-called right answer, which people tend to, maybe who don't know a lot about AI, think, it's like spitting out the right answer. How important do you think that kind of understanding is for the sort of decision support tools that we have been talking about in this webinar? So maybe that's more broadly. I'd like to, maybe Kate can answer that, and
Why don't I start, and then I'll hand it off to you guys for specific examples of what you do at Duke around training. So I think this falls into the bigger category of AI explainability and what is it that the end user really needs to understand. And oftentimes what happens with AI outputs is there's a mismatch between what the AI is saying and what the user knows from their own experience. And in fact, that's why we're building these solutions in the first place. But that can make it very difficult for the end user to trust the AI recommendation. So one thing I would say is I think it does depend on what domain you're in. So in healthcare, it's different than, for example, I have a project with some colleagues from Harvard on fashion allocation. Okay, so there, we're not so worried if the end user doesn't understand, they can just, go with it, fine, that's not going to affect anyone's life chances. In healthcare, it's a different situation, so you need a different level of explainability. One thing that I've seen that's really interesting, some work at MIT, is during training, giving the end user some simulation so they can see where are the places that the AI solution is very accurate and where is it less accurate, so that as end users, they can get a feel for where they should be overruling the tool. But with that, Mark and Suresh, maybe you could talk about what you guys do at Duke around this.
Yeah, please.
So Mark, I can start on a similar spectrum. So Kate, I'm from Northern California. I have a lot of friends who work in big tech, and there are industries where most algorithm development is done on embeddings of the raw data, where nobody on the engineering team can tell you what any one individual feature even is, because it's some mapping to many different transformations of many different raw data elements. And that was completely foreign to me. So even talking about the explainability or interpretability of a model input, I would say that for us is almost non-negotiable, where we have to be able to tell clinicians what is used in the algorithm. What are the discrete data elements? Here's a list of them. Here's what their distributions look like in the population that the data was trained on. So that's one piece. The other piece, and we're actually going to be working with Kate on this in the upcoming year, is doing extensive interviews and prototyping of documentation for different types of stakeholders involved in the adoption process. So an end user may want to be able to, per se, double click and see additional information about the algorithm, what the indicated use is, what the population demographics are for validation of the tool. Whereas a business unit leader who's making the decision, do I move forward with adoption or not, they may need much more extensive validation studies. And the other thing too is just professionally, there's norms in healthcare for how to validate and disseminate literature related to new innovations. So I think some of this has to map to the norms within your own industry for how you build credibility in a tool that's going to be adopted by an organization.
Got it. Thank you. Well, we have just a few minutes left, so I wanted to give you a chance for some parting thoughts. Kate, you want to put a cap on this for us?
Yeah. Okay, I'll try and tie this up. I think the reason why we're so excited about doing this research is AI is such an important space, and it's so important that you're all working in this area because it has huge opportunity to impact the world in a positive way. The reality is right now, the performance is not matching where we want it to be. And so we all need to be learning from one another, taking on new ideas, iterating, developers. For you guys, I'm sure it feels like every day you feel like you solve something. The next day you wake up and you get hit by a ton of bricks and you have to start over. So, like try, fail, dust yourselves off, iterate. C-suite leaders, do what you can to support the development teams, remove any roadblocks you can. Researchers, share your findings. Funders, keep funding. But as we do all that, I think what's really important is not to forget about the people on the front lines, because they're the ones that are going to bring these AI solutions into the real world. Thank you.
Absolutely. Thank you, Kate. Well, that was great. Thank you, Kate, Mark, and Suresh for sharing your insights. This has been a wonderful and really informative hour for us. And I also wanted to thank Five9, our sponsors today. For our audience, thank you very much for joining us today, and hope you'll join us again for another SMR webinar.